Welcome back. In our final lesson in this unit, we're going to sort of switch gears and talk about graphing functions if we're given a story. So a big part of functions is trying to look at a story, look at something happening in the world and being able to represent that in a graph. So we're going to start off with a story about someone walking along a road. After you hear this story and see this graph, you should be able to write your own story or description of a function given a graph, and you should be able to sketch a graph given a story or description. So here's our graph that I'm giving you. Example 1, every morning Tom walks along a straight road from his house to a bus stop, a distance of 160 meters. This graph, d of x, so distance of x, shows his journey on one day. So this sort of looks like, let's take a step back. We're looking at a graph that is increasing, then decreasing, going down, increasing again, and then staying the same as a constant. This should sort of be review for you guys from middle school, that a graph going, when you read this left to right, if it's going up, that's increasing. If it's going down, that's decreasing, up, increasing, and a straight line means staying the same. And since we're looking at distance, we're looking at distance going up, distance sort of going back, distance going up again, and then distance staying the same. So I've got some questions to ask about this graph, and we're going to take a look at one at a time. So the first question we're going to look at is just a basic, is this graph a function, right? So this graph is a function. And how do you know? You know in two ways. You know that each second represented by x has only one distance, which is your y. Okay, each x has only one y. You also know this because if I draw a line anywhere on this graph, that's going to be only passing through one point. So it's passing that vertical line test. So that's the first thing we want to look at. The second thing we want to look at is this graph continuous or is this graph discrete? This graph is continuous. All the points are connected. And there are no breaks or gaps. He's walking that entire time, goes on forever and ever. We don't just skip time. So it has no breaks or gaps. Time goes on. It is a continuous function. The next thing we need to look at is, what does the x-axis represent? So when we have a graph, remembering that the horizontal line is our x and the vertical line is our y. So what does the x-axis represent? Let's use a different color here. The x-axis represents time in seconds. If I'm looking at the x values and I'm trying to find domain, remembering that domain is your farthest left to your farthest right. So the very farthest left is time starting at 0. So my time starts at 0, use a bracket because he is at 0 time when he starts his journey to the bus stop. That's when the time starts. When does this graph time end? The graph ends at 120 seconds. So we're looking at time going from 0 seconds to 120 seconds. What does the x-axis represent? What does the y-axis represent? Well, the y-axis is the up and down. So my y-axis starts here at 0. That means the distance is 0. He hasn't gone anywhere. So we're looking here at distance in meters. And he's starting off at 0 distance, which we can also call that home. Remembering that when we look at the original graph, he's starting from his house. So that distance is 0. He hasn't gone anywhere yet. He's just still at his home. Okay, the range, sorry, I keep going up and down. That's the lowest point at 0. The highest point is this 160 right here. That's as high as it goes, which means that he only went 160 meters. So the range goes from 0 meters to 160 meters. So, and that represents the bus stop. The bus stop is 160 meters away from home. Okay. Let's move on to looking at this in function notation. So now it says find d of 50. Remembering that function notation, this is your x, that's your seconds. So this is saying at 50 seconds, what is the distance? So if we look at 50 seconds, I'm going to scroll back up here. I'm going to erase the vertical line test here. If I look at 50 seconds, that's right here, and I draw a line up to the distance, what is that distance? 100. So d of 50 equals 100. What does this mean in the context of the story? Well, I'm even going to add that this is your y. Well, actually, it's going to be your distance, which is still your y. So that represents your distance. So what does this mean in the context of the story? It's saying that after 50 seconds, he has moved 100 meters. This is what I want you to be able to do. I want you to be able to look at a graph, look at function notation, and make that connection that means something in the story. The next question says, if d of t equals 40, what's the value of t? Well, now we've sort of switched gears. Now we're saying when the distance is 40, what is my time? Well, this should be to x here. If d of x equals 40, what is the value of t? We're going to call this x. Okay, so that is saying that what is the value of x? Well, let's look at the distance of 40. So I'm going to erase this just to make it a little more clear. If the distance is 50, sorry, let's look back here. Oh, if the distance is 40, looking at 40, that means if I look right here at 40 and I go over, what is that x value? It's 20. Okay, so at d of 20 equals 40, that means that x equals 20. Also means that time equals 20, which is why I had d of t. But I really want you to understand that it's your x-axis. That's really important. So d of 20 equals 40, so that means that x equals 20. What does this mean in context of the story? It means that after 20 seconds, he has moved 40 meters. Okay. The next question says, why would d of 100 equal d of 120? So remembering that this is your, this 100 is your time, and this 120 is your time. It's your x values. Okay, so these are your x values. So d of 100 and d of 120, well, let's go look at our x values of 100 and 120. So here's 100, here's 120. If we go up and find the y, you're going to notice that it's at the same time. It's at 160. So that's why. They're both at the same time. So they both mean he was 100 oh, sorry, not 100. He was 160 meters from home after 100 seconds and 120 seconds. In other words, if we think about this, if he's 100 meters from home after both 100 seconds and 120 seconds, that means he's standing still. Time is passing, but he's at the same place. So he's standing still, okay? And so that's really important, understanding that as time is passing, he's farther and farther away from home. That distance shows distance from home. And if we have a constant, if we have this here at a constant, it means he's not moving. Okay. The other thing I want to talk about is this graph goes up and down and up again, increasing, decreasing. And so a lot of people think that this means he's going up a hill, down a hill, up a hill, because it kind of looks like a hill. But the reason that the graph means he's not going up a hill, so this is saying no, he's not going up a hill. Let's use a different color. So no, he's not going up a hill. And how do we know? Because this graph represents distance. Not height. That's really critical that we understand that. So what could have happened during this whole trip to the bus stop? We've talked about some places he stopped as he's moved, but what does this graph mean altogether? So let's look at the graph again. Okay, so I'm going to say he's increasing, decreasing, increasing. But if we look at this right here, and we are understanding that this right here is home, then this means he's probably walking because his distance is increasing. He's probably walking towards the bus stop. So the first thing he does is he leaves home and walks. Walks is critical here. Probably towards the bus stop. So he's walking towards the bus stop because his distance is increasing. He's getting farther and farther away from home. Then what's happening next? What's happening next is this graph is decreasing. This does not mean he's going down a hill. If his distance is decreasing, it's going from 100 down to 40, it means he's going back. Let me get a different color. It means he's going back to home. Now, he hasn't gotten all the way home. All the way home would mean he gets here. So he hasn't gone all the way back home. But what might make him walk back from home? He's walking away towards the bus stop. I bet he forgot something. I bet he went back, maybe dropped something. Maybe something fell out of his backpack. I think that's what that graph is representing. He's going back towards home. The next part of the graph, scrolling back up here, the next part of this graph is increasing. Now, notice that if we compare this part of the graph to this part of the graph, this thing I'm circling, this increasing, is much more tilted. It's a bigger slant compared to this. So that means he's moving more distance over time. So if he's moving more distance over time, I'm going to think he's probably running now. Maybe he realized he was getting late because he had to go back. So he's running towards the bus stop. That's why I'm saying this difference between walking and running. Running is a higher slant of the graph, and walking is probably the lower slant of the graph. Okay. Then what happened last? Well, what happened last, if I go back up, is this part right here. That means he's not moving. Time is passing, but the distance is staying the same. So if he's not moving at all, he probably got to the bus stop and he's waiting for the bus after he ran. So this is your ability to tell a story based on a graph. Okay, I want you to be able to understand what the x-axis and y-axis represents. I want you to be able to find the domain and range, use function notation to find whatever the x-axis is representing and the y-axis is representing. And I want you to be able to tell a story by looking at it. After this video and after you've completed it and taken good notes, you're going to not move on to the practice and the spiral. You're going to come to me and get an activity you're going to do with some more of these Tom stories. Okay, so I've put that in your notes that don't move on before completing the activity, and you won't take mastery until you do that in the practice. So please be sure that you do that and come to me and ask for that activity. Okay, again, if you have questions, please come ask, and good luck.